Hello everyone. So I am Dr. Manjunath, Assistant Professor in the Department of Chemistry, BMS College of Engineering. So today I am going to demonstrate one of the instrumental methods of analysis, that is nothing but flame photometry. So this flame photometry is one of the important spectroscopic technique to determine the dissolved alkali or alkaline earth metals present in the given water samples. So let us see how to determine the presence of some alkali metals. Especially, I am going to demonstrate the determination of the presence of sodium in the given water sample. So this blue color flame is obtained for only distilled water, because distilled water is free from dissolved ion, like for example here sodium. So there is no sodium, hence it is not imparting any golden yellow color flame. That's why we are observing characteristic color of that flame. So we'll observe blue flame for this distilled water. So what is this flame photometry? What is the principle of this flame photometry is very important to study before going to do the experiment. So this flame photometry is nothing but the determination of the intensity of light emitted by the elements like sodium or potassium, etc., that is present in the given water samples. The intensity of the emitted radiations that will be correlated to the concentration of the ions present in the given water sample. So what is the basic principle behind this technique? So when the alkali or alkaline metals, when we expose it to high temperature, like here we are using flame. So when these ions reaches the flame temperature, so the atom excited to higher energy state, there it is unstable, hence it comes back to its ground state. While coming back, it gives the characteristic wavelength. That characteristic wavelength falls in the visible region of the electromagnetic spectrum. Therefore, the characteristic wavelength gives the type of element present in the given water sample. For example, here to say sodium. Sodium, when it is present in the water sample, when it gives the emission after thermally excited, so the wavelength corresponds to 589 nanometer. That is nothing but golden yellow color. That golden yellow color that falls in the electromagnetic spectrum, that is in the visible range. So now let us say the instrumentation part. What are the different parts of this flame photometry? This flame photometry consists of these different units, like burner. It is all the things what I am going to explain, that is assembled here. It consists of burner, nebulizer, and after that it consists of monochromator or filter. So after that it is having the detector, that is very important, and display unit. This display unit gives the intensity of that light emitted, that is converted into current, that is going to display on this display meter in this flame photometer. Apart from these, we have the compression unit. This compression unit helps to send the required amount of fuel and oxygen to the burner. These are the different parts of this flame photometry to say. So now let us come to the experimental part. So the instrument is now ready to work. So it is calibrated in such a way that, so we have the sodium solution as well as distilled water. So distilled water, it is pure water, no ions are present in the water samples. So the instrument should give 0. That means to say that 0 reading is because of no sodium atoms or ions present in the given aqueous sample. Similarly, we have set the instrument to maximum reading. Suppose if I prepared 100 ppm solution, so I set it to the maximum reading. So now the instrument, I will set it to 0 for distilled water. So this is for distilled water. Now we need to send the standard solutions of, that is, it contains sodium ions. So let us see how to prepare the standard solutions. Before going to make the standard solutions, we need to prepare stock solution. So we have prepared the stock solution of 100 ppm by dissolving 0.254 gram of sodium chloride in 100 ml of water. So that is 100 ppm solution. That 100 ppm solution we have taken into different standard flasks of volume 50 ml. So how much solution that I need to take here is, so I took, see here we have labeled the flask like 1, 2, 3, 4, 5 and 6 for our reference. So first I will fill the stock solution of sodium chloride solution. So 2 ml into this flask number 1 and 4 ml to flask number 2, like 6 ml, 8 ml, 10 ml to flask number 5. So after taking that required or specified volume of the stock solution into this flask, we have to make up the solution to the 50 ml volume by using distilled water. So I took 2 ml of the stock solution into this flask. Now I will add water up to the required volume, that is 50 ml. So always we have to use distilled water, that is very important. Now the solution made up to the mark. The total volume of the solution is 50 ml. So similarly, I have prepared other solutions by filling the distilled water up to the mark. Now the solutions are ready. Now we have to go for measuring the readings for various standard solutions. Like for example, what is it? Flask number 1, 2, 3, 4 and 5. And this is, flask number 6 is the test solution. Test solution in the sense, the solution whose volume as well as concentration is unknown. So for this test solution, we should find out what is the concentration of the sodium present in this test solution. That is what the aim of the experiment. For that thing, we need to prepare the standard solutions. So we'll come to know why we need to prepare the standard solutions later. So the instrument is ready. The instrument, it is showing 0. Now I will place the standard solution 1. That is, I have filled 2 ml of stock solution and remaining is water. Before going to place into this sample cell, we have to rinse it thoroughly and then we have to take the solution. Every time, remember, after every time we have to set, what is it? Set for 0. Otherwise what happens, some ions it may be present in this nebulizer, that also gives some intensity. For that reason, we have every time we need to set it to 0 with the help of distilled water or pure water. So now I place this in the test solution number 1. So we can say that before this the flame was blue, now the flame is, what is it, golden yellow flame. The reason for the golden yellow flame is that whatever the sodium chloride solution we have placed, that was aspirated and pumped into the flame. Because of that flame temperature, the sodium atom so undergo excitation. So after excitation, it must show de-excitation. While de-excitation, it gives the characteristic color. That characteristic color that can be observed in the form of golden yellow color. So we can clearly see the golden yellow color. So this is the intensity of light is correlated to the concentration. So we need to note down the reading which is displayed on the digital board. So once if you note down the reading, now we have to go for the next solution. Before going to the next solution, we need to clean this by using distilled water. Again, place the distilled water and then clean it. Make sure that again the instrument, it gives the 0 reading. So next, place the sample number 2 and wait for some. Again the same process that takes place, and we will get the readings that will be displayed on this digital board. Before that, again and again, I am telling what is it, we need to clean it by using distilled water. Now the third sample we need to place. Sample number 3. So almost the reading which is almost stable. Now let's go for the next solution. Before that, again clean it with distilled water. Now we are moving to the sample number 4. So let us move on to the next sample, that is sample number 5. Before that, clean with distilled water again. After every trial, we need to clean it using distilled water. So place sample number 5. So we took the readings for all the standard solutions for sample number 1, 2, 3, 4 and 5. Now we need to place the test solution. The test solution whose concentration is unknown. For the standard solutions, the concentration is known. So we came to know the instrument readings, and finally we have to note down the instrument reading for the test solution. So place the test solution and note down the instrument reading. Right. This is the instrument reading for the unknown solution or test solution. Once, if we note down the instrument reading for the test solution, we need to plot a graph of the volume of the solution in the x-axis and the instrument reading in the y-axis. So if we plot a graph between this volume as well as instrument reading, we will get a characteristic graph, that is what a calibration graph, in such a way that we will get the graph like this. That is maximum number of points that will fall in the straight line. And for the test solution, what we should do, first note down the instrument reading in the y-axis and draw a line towards this straight line. And where it meets the straight line, from that point of intersection, drop a line towards the x-axis. When we drop the line towards the x-axis, where this line meets the x-axis, that corresponds to the volume of the test solution. If you know the volume of the test solution, we can calculate the concentration of the sodium present in the test solution. This is what the calibration graph. From this calibration graph, by knowing the instrument reading, we can calculate what is the volume of the test solution taken. By knowing the volume of the test solution, we can calculate the concentration of the sodium present in the given test solution. This is the experiment, and all the readings we need to tabulate, and we have to plot the graph by using these values. Thank you very much.